Hi guys, welcome to again to my channel. My name is Malasa, and in the previous tutorial, I have already shown you how to assign different types of loads to the this Tuning story building. And we have already applied all the gravity loads to this Tuning story building. Today I'm gonna be show you how to apply the lateral or the soil pressure load to this tuning story building, which is specifically to the retaining wall. If you are a new comer to this channel, don't forget subscribe my channel so that you will be getting new updated tutorials regarding to the designing of these tuning story buildings and the steel structures. If you have any questions regarding to the design of reinforced concrete structure and steel structures, you are always welcome and provide me your comments in my commenting box so that I will be answering your questions as much as possible within a short period of time. And also don't forget press the bell icon so that you will be getting an immediate notifications for the new released and updated tutorials. Don't forget also share all those videos to your friends so that your friends will be getting all the tutorials regarding to this only story buildings and steel structures. So now let's proceed to the today's tutorial, so which is tutorial number 15, the application or the assigning of the lateral load to the retaining walls. Now let's get started. The lateral loads are nothing but those are loads which are applied to the structures in a horizontal directions. Here we have a retaining wall here. Here we have a retaining wall here. This here we have a lateral load which will be applied to the retaining wall due to the soil. So this lateral load has to be applied to the walls properly. So to do this, ETABS has an option of the application of this lateral load, which is just we can get here just the assign just to go to the assign menu and go to the show load and here non-uniform load. So this non-uniform load, why we cite it non-uniform load, because here the loads is not uniform. So it will be maximum at the bottom of the retaining wall and it will be minimum at or zero at the top of the retaining wall. So here the distribution looks like this one. Suppose if we have just like this, just like this here, it is, the distribution is just like this, which is non-uniform load distribution. So to do this, just to do this, I have already prepared the spreadsheet which is regarding to the application of the non-uniform soil pressure load to the retaining wall. Here, you know, this is the total height of the wall, which is around it is 11.6 meter. That means here starting from this up to this, that means the total height of the retaining wall is, it is 11.6 meter. So here here we have the formula which is showing the magnitude of the lateral load, which is P, which is equal to AX plus BY plus CZ plus D, where A, B, C, and D are the constants, which can be obtained by the application of the soil pressure load at the bottom and at the top. Here we are at XY plane, so that means, the load is applied in a vertical direction. That means along Z direction. So the X and the Y values are going to be 0 because we are applying along the vertical direction. If we are applying the soil pressure along in x direction, so y and z will be 0. And also in similar way, if we are applying along the y direction, so x and z will be 0. So here, as the soil pressure is applied along the z direction, so x and y will be 0. So if this and this is 0, so this value will be 0. So what is left? P is equal to cz plus d. So this is the formula that we are going to use for the determination of constants. Okay, now here the soil unit weight, that means gamma from the geotechnical report, which is 18.0 kilonewton per meter square, and the other is a surcharge load. That means that is 12 kilonewton per meter square will be applied as a surcharge load. Here, this is a surcharge load. This surcharge load is due to the loads of the vehicles, and the loads due to the dumped selector material, or this is the load due to the dumped construction material. So those loads will be considered as a surcharge loads, and usually surcharge load of having a magnitude of 12 kilonewton per meter square is considered. And the height of the wall, that is 11.6, as I have already said. Angle of the soil friction, that is phi, which is equal to 30 degree. This is described in geotechnical report that I have already shown you. And sine phi it is 0.5. It is provided and described in the code. And the ranking coefficient for active soil pressure it is 0.3. How it is 0.3? Just we can substitute the angle phi, this phi, into this and into this, and finally we'll get 0.3. And ranking coefficient for soil pressure for surcharge load, which is the formula that means cannot at rest condition. That means if we don't apply any soil pressure at rest condition, so cannot will be 0.5. How it comes? Simply 1 using this formula, 1 minus sine phi. So if we substitute phi, which is 30 degree, into this, so we'll get 0.5. Soil pressure at the bottom, that means here the soil pressure at the bottom will be this one. The soil pressure at the bottom will be just we can calculate it using this formula. That means the soil pressure at the bottom will be the constant, the ranking coefficient due to the soil pressure times gamma of the soil times the height of the soil. So finally we can get that is 69.5 kilonewton per meter square, which is here 69.5 kilonewton per meter square load will be applied at the bottom, and at the top it becomes 0 because there is no any height. The height will be 0. So here the soil pressure is 69.5 at the bottom, and at the top it is 0. And when we come to the surcharge load, also here the total pressure for the surcharge load, surcharge load, this one will be equal to K naught times the surcharge pressure. That means the 12 kilonewton per meter square, which I have already defined, that is 6 kilonewton. So here there is a 6 kilonewton per meter square surcharge load will be applied at the bottom and at the top, because this the vertical surcharge load will be converted into the horizontal uniform load. So it becomes 6 kilonewton per meter square. So having this in mind, we can adapt the soil pressure and the surcharge pressure, which will be applied at the bottom of the retain. Here the total pressure for surcharge and active pressure at the top of the total pressure for surcharge and active pressure at the at the top of the wall also, that means, which is 11.6 ps is equal to, that is the soil pressure load will be 0, and the soil pressure P2 will be equals to 0 plus ps. So it becomes 6 kilometer. And when we come to the calculation for the coefficient, simply we can use this formula. Simply we can use this formula. So at this equal to 0, that means at this point, here just we can come to here. At z is equal to 0, at z is equal to 0, then P1 is equal to CZ plus D. That is using this formula. P1 is equal to C1 plus D, and which equals to 75.5 minus 0, that means 75.5 is the pressure at the bottom of the retaining wall. So D equals to, how much is it? It is 75.5. So D is, it is this constant D. When we come to etabs, here we need to calculate all those constants A, B, C, D. So A and B, I have, as I have already said, it is 0 because the loads are acting along z direction. So A and B are constants associated with x and y. So x and y becomes 0, then A and B becomes 0. Then what is left? C and D. So we need to calculate C and D. So that is why we are already discussing about the calculation of those parameters. So D equal to 75.5, and at Z is equal to 11.6. That means at top, at Z is equal to 11.6, then P2, which is equal to CZ plus D. That means P2 is, it is the pressure due to the surcharge load. So surcharge is 36, which is equal to 11.6 times C plus 75.5. So 11.6 is the height, that is Z. So finally we'll get, that is minus 6. So C is equal to minus 6 and D is equal to 75.5. So here this is the spreadsheet which shows when we just put the inputs, then automatically we'll get the value of the pressure and the constants of C and D. So here, before the application of the load, we need to check the orientation of the local axis. So to do this, we need to select the retaining wall. So go to here. Section. So we need to select all the wall. Just come to the ground floor and select this one. Okay, sorry. Select one story, make it one story, then you go down. Okay, ground floor is not selected, and this one. So make it so. Show selected object only, make it as ready. Okay, that's perfect. Okay, now let me see the orientation of the local axis. So, so show the local axis orientation. Okay, now here go to the display option here, the local axis. Just make object show local axis. Sorry, this is the orientation of the local axis. Okay, now here the positive z direction has to be applied to the inside parts of the building. This is correct, and this one is also This one is also correct. And here we need to reverse this one. So to do this, we need to select to select this one, this, and this. And we need to see also on the other direction. Okay, here this has to be also reversed. This one is okay to the inward direction. Okay, this one is okay to the inward direction. This one is okay to the inward direction. Now this is all about the selection of the shells having the positive z direction out of the building. Okay, now go to the edit menu, then go to the edit shells, then reverse the one local axis. So when I click this one, this local axis will be reversed. That means into this direction. Now here in this direction, and when I click this one, it will be changed. Just look at the local axis here. This one here, it is reversed, but I didn't select this one before. That's why. So go to the edit menu, then edit shells, then reverse the local axis. Now it is reversed. Okay, now check all the shell elements. Here now it is reversed. Here now it is reversed. Okay, perfect. Here all are reversed. Okay, so we need to select the words and now apply assign the shell load, which is the shell load non-uniform load. So just come to here, so select the swell pressure load type. Then here local axis, sorry, we need to select the local axis because we need to apply the swell pressure along the local axis 3, that is along z direction. So here come to this spreadsheet. Now D is 75.5. 75.5 and C is now C is this minus 6. This minus 6. Now apply. Here this subsoil pressure, local axis 3. So now apply. Okay. Here the soil pressure load is applied on the wall, that is along z direction. Okay, now click OK. So make it save. So this is I think all about the application of the lateral load to the retaining wall. Here we have the core wall. This one. Now here the soil pressure is applied starting from at the bottom of the retaining wall to the top of the retaining wall, and it will be maximum at the base, and it will be zero at the top of the retaining wall. That means at the ground level. But when we come to the core walls, here, the insignificant portion of the core walls are subjected to the lateral. So that is better if we ignore the effect of the retaining or the soil pressure on the core walls. Because to do this, so we need to go to the plan view. So here we have previously applied the soil pressure. So we need to delete the thus applied soil pressure on the internal core. So to do this, just we can select this one and this one and this one. So go to the assign menu. So the shell load, non-uniform load. So here we need to delete the applied non-uniform load on the internal forwards. So select this one and apply this one. Okay. Here there is no any applied lateral loads here. Okay. Click, save it. Okay. Thank you. So this is all about the today's tutorial, which is tutorial part number 15. So next time I will be showing you the post-analysis behavior of the this 20-story building. The deflections, that means the vertical deflections, the displacement, the lateral displacement, uh, and also the behavior of the modes that means the behavior of the structure against the modal analysis or the dynamic analysis, and the behavior of the building against the static load cases. So all the responses of these structures against the applied load will be dealt in detail for during the next tutorial, which is tutorial number uh, 16. So if you like this video, don't forget just sharing to your friends, so that your friends will be getting the new updated tutorials regarding to this theory story building and this structure. And also, if you are a new member for this channel, don't forget subscribe my channel, so that you will be getting all the tutorials regarding to this tuning story building. And also, if you want to get a notification for the immediate updated tutorials, so just press the bell icon so that you will be received the updated and the uploaded videos within a short period of time. So if you have any questions regarding to the designing and the modeling parts of this story building, as well as any civil engineering projectors, so you are always welcome, and provide me just your comments in my commenting box, and I will try to answer your questions as much as possible within a short period of time. So see you next time with tutorial part number 15, that is the description and the presentation of the post-processing responses of this story building against the different types of cases. So see you next time. Bye bye.